Right. Today is the first lecture. WIA2004 operating system. My name is Saidar Razali Azuri. I'm a lecturer in Department of Computer System and Technology. Basically, it's a network. This subject operating system is a compulsory subject. It's a core faculty subject for all the students, regardless what your courses are. Either you are network, software, AI, multimedia, IS, or something else. Okay. So, what is an operating system? I think you all know that operating system for PC, they have Windows, you have Mac, and of course you have a Linux. So maybe you guys familiar with the Windows or maybe Mac. Maybe some of you have used Linux before. There's a Unix which is Linux based and others. Operating system for mobile computing is like Android and then iOS. Last time they have Windows Mobile, but already and last time they have a Windows Mobile, and before that the first one is a Nokia, what we call that, Symbian or something. So it's already defunct and discontinued. I think Windows Mobile also like discontinued. So now you have Android and iOS. So what is an operating system? Basically, is the boss of a computing system. Is an operating system is the executive manager of a computing system that manage all the hardware and software. So you can imagine this like like light switch. Okay, you have here like a switch, and then you have here lights, and then between all this you have all the wiring inside the building and stuff. So this is the part of OS. This is the part that OS control. Okay, and of course the interface as well. So in order for you to lights, you must have some interface or OS here, and all the remaining here. You can have without the switch. You can also on the light, but you have to know all the the wiring stuff inside here, which is become too tedious, too difficult, and sometimes it's dangerous as well. So that's why you have OS that control interface between the is manage all the hardware and software. So in this case, the hardware and lights. So this OS control everything. Here is a OS. So it control every file, device, section of main memory, and nanosecond of processing. So basically, in computer, you have memory, RAM, and processor. So uh, there are four managers of an operating system. The first one is a memory manager, or what we call that a RAM, random access memory. Random access memory is a volatile, meaning that if you if you power up your system, the memory will remains there, but if you off the system, it will be lost and everything. So it also checks validity of each request. If request valid, it allocates a portion of memory that is not in use. So basically you have a big chunk here of memory. So this is like part of it is taken by OS, and this is all for the basic memory management. You have all this to you can use all this to allocate a job. Okay, allocate a job. So some jobs needs more as a job one, job two like needs more job three, and so on. So this is the memory capacity. Okay, it also deallocates memory. Let's say job one already like finished, so you will remove job one. Okay, you will remove job one so that you will become next job will go into these empty slots. It also preserves space in memory occupied by the OS itself. Cannot allow any part of it altered, exit or in. So OS will occupy some of the main memory. Okay, some of the main memory spaces. So this one you cannot alter, or you cannot like accidentally altered or intentionally altered. This is like protected, but others you can allocate a job. And then you have a processor manager. Processor manager means the CPU, central processing unit, is the heart, is the intelligence of the system. It determines how to allocate the central processing unit CPU. Okay, a CPU have their own memory called cache. So this is CPU, this is a cache, and this is the main memory RAM. Your RAM. So some smaller CPU have their own cache memory, which if like you want to execute certain things that you always do, so you a small one you can put in the cache memory, which is more faster. If not, you have CPU have to go to the RAM to to see the jobs, which jobs he wants to execute. It keeps tracks all the status of each process. A process is an instance of execution of a program. Okay. It also monitors whether the CPU is executing a process or waiting read-write command to finish the execution. So we have a read and write command. I think you know read meaning that you only can read, you can alter. Write, you can alter the file and stuff. It also handles a process transition from one state of execution to others. So this is a process when you have basically in the operating system basic you have five states, which is hold, ready, run, wait, and finish. Okay, a state in the processor manager. So you can imagine this as like a car, racing car. Okay, racing car. Before it, okay, this is the car, and this is the starting line. So before it execute, it will be in the whole situation. It doesn't. And then when the flag is up, it's on the ready state. And then when it's like run, the car moving to the track, okay, and then run, wait, run or finish or something like that, and then the car will go to the finish line, which is finish. I think already wait, run or wait if like let's say there's like accident or there's a rain in the track, you have the car has to wait for a while until it finish, and then it will go to the finish line. So they have four states of the processor manager. So it will reclaim the processor. Processor also like the memory, they have allocate, they have spaces. So when the job is finished, the CPU will reclaim the processor or allocate a new jobs or new process to be executed. So in the processor manager, you have two job scheduler. One is processor manager. You have a two scheduler. One is a job and one is a process scheduler. So job is basically job is a big thing. So you have a process one, process two, process three. Oh, sorry. What? Sorry. This is job. You have a process one, process two, and process three. So job is the big one. Process is a small that you can okay like job like you can say like job you want to clean the house. Okay, some will clean the bathroom, some will clean the living room, some will clean the main bedroom, some will cleaning the garden and stuff. So this is like the big job is cleaning the house. So the process is like specific, like cleaning the bathroom, cleaning the room and stuff. So this is what basically what job scheduler and process scheduler meaning. So processor like job scheduler is more like high level portion, and the process scheduler manage a process within each jobs. So like a processor scheduler also decides which process gets the CPU and for how long. Maybe to clean the living room, let's say you give a priority. Clean the living room is much more is given higher priority than cleaning the main bedroom. So you have to start with the cleaning the living room and so on. So each manager must work harmoniously with other managers. Okay, meaning that the system must be in a steady state, stable and stuff. Okay, so basically you have here user command interface. this is like CMD in your CMD or hyperterminal in your Windows. Then you have a processor manager, memory manager, device manager, file manager. Some of the new I mean now the modern operating this is for basics, but now some of the books they call a network manager, some security manager, and so on. Or this is just a term that used by some of the textbooks or some of the definitions, but all agree that in the system managers we have processor, memory, device, and file manager. Okay, so device manager basically monitor each device. You can like right click if you have a Windows system. You can right click on the My Computer. You can see properties. You can see the device. You can also like device manager. What is the command? I can't remember. But you can see the device manager whether your mouse, your keyboard, your like your interface and stuff, all your hardware, all the components that build up your laptop or PC is in there for your device manager. So you also choose the most efficient way to allocate all the system devices, printers, terminals, this and that, so on. So you also make the allocation like USB port. Sometimes you use mouse, or sometimes you use other things. So when you use that, it allocates. When you disconnect that, it deallocates the device. Okay. Mostly your like plug and play device like USB or HDMI ports, something like that. Okay. And then you have your file manager. You have your file manager keep tracks all of all files. Okay, where file manager where you can hide or you can hide the file or something. You can also make files. You can also enforce a policy like read write, group only or general access. Okay, keep tracks of all files like data file assemblers, compilers, application programs, and stuff. So you also control types of operation a user may perform on a file, read only or read or write. Read only or read and write. Okay, control types of operations. Also, some of it you like open or if you have a PDF file, whether you want to open with a PDF, you want to open in Adobe Acrobat Reader or PDF XOXO or all others software that can open a PDF. So it also allocate resource when file is open. Let's say you open the Microsoft Word file, it allocate the resources. Resources here means RAM and processor, and it also deallocate resources when file is closed. So when you close the file, you click the X button after you save it. So it will deallocate whatever remaining jobs or process in the CPU and the memory. Okay. So the main memory management, the memory manager is in charge of main memory, checks the validity of each request for memory space, allocates, reallocates. So you have like this one is your main memory. Some of it you allocate to S, which is this one you cannot accidentally alter or unintentionally altered. So this is the space that you want to allocate jobs. So like this one is job one, this one job 2 using a bigger memory and job 3 and stuff. So after like let's say job 3 job 1 finish, so you will enter job 4, job 5, this is in the queue, so job 4 will go here or something like that. Okay, this is a basic operation, but in details it's not really like this. Some of it have a fixed memory allocation, some of it very flexible and stuff. Okay, we will learn about that in the next lecture. So key features of RAM chips, which is like actually a transistor or a chips or a logic gates. I think ROM, read-only memory, which is a non-volatile. Either you uh, either you on or off your laptop or PC, the memory will still be there. That's why read-only memory is a non-volatile. On or off the machine, the memory will remain there. It's basically it's chips. Okay, much more smaller than its capacity, much more smaller than the RAM, and much more smaller and slower than the RAM. So the processor manager decides well how to allocate the CPU. Basically, if you want to see how your CPU doing in Windows System Control Alternate Delete, see the task manager or something like that. You can see how much your CPU allocates, how much your CPU utilization and stuff. Also keep track of the status of each job, process, and threads. Okay, so you have a job, you have a process, and you have also a threads. All this is a difference. All these are different terms. Job, process is a part of jobs, and threads. Okay, process, jobs is the bigger one. Process is part of the jobs, and thread is part of the process. This is basically how you want to understand what is job, process, and threads. Okay. You also monitor the CPU while handling each process transition like traffic controller. Okay. Process management monitor the CPU whether okay the utilization is high or utilization is low. So it's like a traffic controller. Multiple CPUs, yes. Now you have like now Intel core like 4 cores, 8 cores or something, meaning that in one individual chips you have independent. This is a 4 cores, one independent CPU inside of multiple CPU. It can either be like this or you can have a machine with multiple CPU. Okay, which of course for the heavy duty jobs that need a lot of resources and stuff, you can also have one machine like cloud computing or something. You have multiple machines. In this machine they can have one CPU or multiple CPU as well working together. So this is what I call a multiple CPU. It all mostly the work are all done in a parallel way. So device management, again, this is like your device manager. Okay, you can right click your properties, your my computer if you're in a Windows, you click the properties, and on the top left you have a device manager. You can see if your like device is not installed properly, you can see like a yellow sign on that on the icon. So basically device management is responsible for connecting with every device that is available on the system, choosing the most efficient way to allocate each of these printer spots, disk drive, and more base device scheduling policies. Okay, yeah, basically it handles all the device that components that make a system, or like printers, your drive, your RAM, and all others. Example, just look at your device manager. For Linux, I think in UDEF or something, in UDEF you have to use a command line. I'm not sure about Apple because I'm not really an Apple user, Mac user. But you have every operating system have their device manager, meaning that your hardware manager. Okay. So file management, your file, your PDF file, your .s file, your .c file, everything, whatever file you have, file management will manage it. It keep tracks of every file in the system, including data files, program files, utilities, compilers, application, and so on. So it also enforces restriction on file access control. Some of the file you can only read mostly on the Windows. I mean, you have a Windows file, Windows folder, Windows 32. You cannot like modify it. Some of the system file you cannot modify. And if you're in a network share folder system, you can like restrict other this file can be. Of course, if you are in one machine with multiple users, everyone log on. I mean, each different users will log on to their own to their own user system, which they have their own file. So you can also enforce restrictions. Like, let's say you have everyone shares a file the same file system like inventory. You can share files you can enforce like only certain people can read or you can write. Everyone can read the inventory files, but some of the people in charge that can only write if like inventory you want to add some stuff, you want to add some device or stuff. So this is like enforced restriction: read or write, or read and write, something like that. So it's a file management. So network management only for OS with networking capability, which only with OS with networking capability, which is all at the moment. I mean, I think last time also, let's just start with the, not sure when, which OS. Like, I mean, now all OS can handle the networking capability. Okay, provides convenient way for authorized users to share resources. This manager must take overall responsibility for every aspect of the network connectivity, including the requirements of available devices such as well files, memory space, CPU capacity, transmission connection, and types of encryption, or if necessary. Meaning that if you share a folder or something, you can put you can put a password in order for you in order for people to access. You don't want unauthorized access, you can put a password to certain folders, or whenever someone's want to, if you have in a network sharing office, you can put a password if anyone tries to open the files in your machine. So this is network management. One another one is like security management, which is all new. So basically, it handles the security, the virus and stuff, antivirus, Trojan, and others. Okay. So a user interface. Last time, if you familiar with Windows, you have CMD, or in Linux you have CLI, command line interface. And you have a Windows, you have a I mean, in Apple they have a hyper terminal. So mostly in an old-fashioned way, you have a command line interface if you want to access whatever file. Okay, you want to create a directory, you can use a command line like in Windows CD, and then you CD and then you create the folder names. But now, of course, easier. You have a graphical user interface. Everything you just click, and that click, right tick, I mean click, tick, or whatever you want. So this is a graphical user interface, which is easier. Command line interface is much more hardcore users. Okay, so we go for the end evolution of computing hardware. So this basically the OS development, uh, operating system development, not a computer. Okay, is the OS development. The first generation computers 1944 and 1955, not much using, they don't really use OS. The second generation computers and the third generation computer from mid 1960s and 70s, 80s, 90s until now is like mostly is a more processor power, more hardware memory, more parallel way of doing programs and stuff. Okay, now in order for the program to be good, you must have both. Must have both capabilities of the computer hardware and of course the software. So in order any programs to be good, both the hardware and both the software or the programmers coding side must be compatible. Last time it was only a hardware. I mean, the software engineer just do whatever software they want to create, and let for the performance they let hardware guys deliver, or let all other problems of performance let the hardware guys handle that. But now, no, you must have both hardware and software engineers in the coding style, like parallel way, to do the uh, to make a program better and faster. Okay, this is a we call OS development. OS is a software. Software control all the hardwares of the machine. So the first computers is basically this is a debate, but in history, mostly in majority, is that Augusta Ada Byron, a British girls, I guess, from aristocrat family, the world first computer programmer, played a key role in formulating a notion of programming the analytical engine. And you know, there's a there's a joke going around why the computer programming is so difficult because it's created by the women. But this is not like a sexist way. This is like to to yeah, because yeah, computer programming, for those who don't interest those who not interested in the computer, they feel very difficult. So some say that because it's created by the woman, it's so complicated. And this is not a sexist or sexist joke, whatever. Just jokes like playing around on the internet. Okay, I don't think even if the male created the programming language, it still be difficult. It doesn't matter. But of course, these are jokes, right? So the first computers in 1991, the London Science Museum with Difference engine using Babbage plans. This is like not the this is not the first computer. Just this one. It's not the first computer. It's like a couple of improvement made from the first one, which is from Augusta Aldebaran or analytical engine. So you have a Babbage plans as shown in this boot card. It works perfectly. This is okay. This is for the can only solve a mathematical equation and stuff. It's very limited processing power. So the first computer also use the vacuum tube technology, and they don't really need operating system. Mostly is a hardware base. Okay, mostly is a hardware base. So the first and then there's also improvement of the that Babbage and other computers. Hillary and the Automated Sensor Bureau of America invented an electronic punching device. So founded by tableting machine company which become IBM. IBM, most of the computer standards that we use, take example for your keyboards, use the IBM standard. So Solaris punch card tableting machines are the predecessor of the today's business machine. Okay, so this the first commercial one, the first like ready to use commercial. It's not really a commercial, like mostly on the government offices or big companies, several companies that want to solve certain problems. They use this one, the Hololith and automated sensors. I mean, sorry, the electronic punching device. Use a card, make a hole out of it like a punch card, and then you process the jobs. So there also an ENIAC created by Dr. John and Mochley. Okay, from Presper Eckert for use in war, but must not complete the time. It was mainly used to solve math problems. So all this solve the math problems. Now you have calculator which is the size of your palm or maybe even smaller to solve some complex mathematical or use MATLAB or other software. So this is like the old calculator last time to solve like 2 plus 3 or something, 2 times 3, which is more complex. Right? So the computer program as well as data is stored in the computer's memory. When we call it computer's memory is a RAM. Okay, the computer memory is well data is stored in the computer's memory. So this is the first generation 1950s a vacuum tube system. The first generation of computers use vacuum tubes. Vacuum tubes fail frequently to for first generation did not work most of the time. So this is like a prototype. It is a IBM. I think they patented it. They patented it. I think I have if you find IBM patent vacuum tube system you can find in the Google Scholar. Doesn't really work. I mean, it works, but not work most of the time. So it's not really a commercial success. But this is the start. So UKIT and Marshall delivered the first UNIVAC to the US Conservatorium in 1951. UNIVAC gained fame when it predicted Eisenhower as the winner of the 1950 US presidential election. Okay, not sure whether you have learned about it. I mean, I think you know all the statistic and stuff. Of course, now like more complex data. Now like you use data analytics from the social media or from others other point of you where you can collect the data. We call it data analytics to predict the election and stuff. But this UNIVAC predicted Eisenhower as the winner of 1952 US presidential election using a statistic solved by these big machines. Okay, solved by these big machines. Uses that. I mean, is I mean all this to determine whether Eisenhower win or not the election based maybe a limited data they have that time and they can predict quite accurately. Okay. So features of UNIVAC, you have easier to use than ENIAC, fewer vacuum tubes, more reliable vacuum tubes, much prone to the failure, a stored program, general purpose, and use machine language. So machine language, I think you will learn in the embedded system how the processor language works. Okay, IBM 701. This is the machine. This is the model of the first generation computer. I mean the modern after the vacuum tubes. For IBM 650. Because of this machine, I think that's how IBM really become successful international business or very successful company because of these two products. And then you have a second generation use transistor. The transistor. So it developed for the held a second generation of computers, which is this transistors is the heart of the even the modern computers where you have logics and everything, gate logics and everything is based on the transistors. Okay. Uh, so everything like process, job scheduling, improve productivity because program with similar requirements can be grouped together for processing. So this is where the Fortran programs, the fault for the Fortran or F language, the F language, or sometimes they use the F sharp. Okay, so this is where the first like programming language ever made. I mean, the first programming. I can say that the commercial or the mass use programming language of Fortran. Okay. Um, Also, the second generations still use punch card of a batch jobs. We call that one by one. You have to wait one jobs to finish before you can execute the others. Okay, punch cards. Use printers, state storage, and disk storage. Use high-level programming language like COBOL and COBOL and Fortran. Okay. And you have IBM 1401. And this is a second generation as well, electronic recording machine accounting or ERMA. And then you have ASCII, American Standard Code for Information Interchange or ASCII code, where what is the binary number for like character A, B, C, they have an ASCII code for that. Okay. And then you have IBM System 30, line of compatible computers, instruction set enabled to be used for both business and science. So this is like the really a commercial one for business and science. Last time it was very expensive, only used like a big company or government bureau. But now it also offers to like a small businesses like IBM System 360. You can, of course, you can always you can like you can always see on the YouTube the tube machine, vacuum tube computers and others like punch card computers or something like that. You can see on the YouTube in the black and white color. So the third generation computers is like the what is the modern, is the base for the modern PCs or machine. It use a time. Okay, last time it used a batch. Last time it used a batch jobs, or we call it a serial if you want. So like have a job one, job two, job three. So you have to wait until job one finish, then you can execute the job two and job three and so on. Which is this a serial of batch jobs based on the batch system. Now they use a time sharing. Okay, they use a time sharing, meaning that job one, job two can like simultaneously execute or something. Okay, or like job one specific time allocated. If not finished, must go to the job two. Access remotely by terminal. So this is the beginning of the network system. Okay, you can access remotely, but use integrated circuits, small, medium to large scale integration, resulting in lower cost. Okay. So the multi-program scheme is constrained by the physical capacity of. I mean, they use like time sharing. They use multi-programming. They want to execute more jobs at one time. So for solution, they use the develop virtual memory to advantage of the fact that CPU can process only one instruction at a time. So with virtual memory, the entire program need not reset the memory. Okay, the virtual memory, the entire program, because from CPU they want to go like, okay, this is a CPU, this is the main memory. Every time CPU want to travel to the RAM, it will take some time. So they have like this virtual memory which is nearer to the CPU and much more faster. Like jobs that small jobs or jobs that you always do, you can put in a virtual memory. Okay. Um, so use integrated circuit, a transistor resulting in lower cost. So the third generation as well, you have more advancement. DESYS microcomputer, DESYS, it's a US company. PDP is like, not sure, I forgot already what's the acronym for that. This is mini computer, many different programming language, IBM unbundled in systems. It is not a PC, but it's a mini computers. But at that time, mini computers is compared to the current times really a giant computer, still a giant computer. Uh, so at that time in 1970s, like wide area networks when developed, when is like the basic for internet. Our partner implement internet protocols, TCP/IP, local area networks, LAN also developed, and mainframes, mini computers, open architecture also developed at that time. So advancement, so milestone, the fourth generation computer, they also employ a very large scale integration of VLSI. So all these electronic components, you can scale it very small into the circuit board. Develop Intel 4004 first microprocessor. I think speed is couple of kilobyte. Not even reach a megabyte. Okay, the clock speed. So this Apple computer also founded 1970 and 1980, the first PC. IBM introduced the personal computer. IBM computers are clones. Computers or clones introduced. Okay. Okay. This is how the first PC looks in 1981. So Intel provided a Microsoft and Microsoft Corporation provided operating systems. This is the basis model that used by our modern system at moment. I think some of it there's like I think eBay. You can find this item in eBay. Some of it working, some of it doesn't really works. But they sell in a very very expensive one. I'm not sure whether you want to buy or not. Okay, but if you have you want to have a collectible item of the fourth generation PC or the modern that basis of our modern PCs, you can have a look. So Apple computer and IBM. You have Apple computer use a Motorola and call a Macintosh or Mac, and Intel you call a PC. So this the fourth generation is the first PC created for the for the normal user, for the single user. So you have operate. This is where the base of the operating system as well. If you can see for Microsoft version provide operating system. So Apple computer Macintosh first commercial personal computer to offer a user interface. So before this, IBM computer use a command line. Okay, command line. If you command line interface, everything they don't have mouse or whatsoever. So Macintosh was the first commercial personal computer you offer user interface, a nice one. And then you have IBM. This is Apple computer, and then you have an IBM that use Windows, Microsoft Windows 98. The first one, I think, the first GUI for the Microsoft is Windows 95, which doesn't have. It's very difficult to connect to internet, by the way. By 98, if you, I don't think you have, I don't think you have ever experienced using a dial-up internet. But 98 Windows 98 provide that function, dial-up modem. So we are still in the fourth generation. The fifth generation, they use AI. I'm not sure, but this is all a definition by the expert. It can be like extension of the fourth generation or so on. But using the use of AI for everything now is the standard. Okay, use of AI. AI has been slow in coming. It's not AI has been slow in coming. Last time, yes, it's still slow, but now it's like rapidly. Every system use AI, mostly on the internet. Like Google use AI, Facebook and stuff. That's why you know. That's why they can know what you want to, what what you want to search or what is your interest. They can suggest to you. So this use all use AI. Fifth generation also. Technologically, we are still in the fourth generation in which engineers are pushing to see how many transistors they can pack on a chip. So now they have a lot of transistors, but it will come to an end. So this effort alone will bring some of the trappings of AI. So the fifth generation computer is not. I mean, you have a quantum computing, supercomputer, everything. Not really sure it can be called a fifth generation, but as the majority of computer experts agree that fifth generation computer mostly will use AI. So there are four categories based on response times and how data is entered in the types of operating system. So you have a batch system last time, a vacuum tubes and stuff, serial jobs, interactive system, which is a extension of a serial, but you can like multiple jobs but limited. Okay, interactive system. And you have a real-time system which is very fast, and you have a hybrid system which is the modern use of both modern PC now still use the serial, and I mean still use a batch and batch interactive and real time. So hybrid is a combination of all three, or some element or some two or three elements of this types of operating system. So mostly now operating system is the hybrid systems. So this is the hardware configuration. You have okay, this a normal PC setup. I think a video interface, video screen, and then you have ALU registers. So this CPU again, you have a ALU which doing all the logics, mathematical registers, internal control for I/O, and bus control. Bus control connected to the main memory, disk controller, serial interface, parallel interface. And of course, you have a keyboard interface, so on. So this is the modern computer setup. Now they don't use a wireless or something like that. Okay. So machine hardware, a computer's hardware is the physical machine and electronics components, main memory where data instruction must be reside to be processed, input-output device, peripheral units such as printers, disk drive, CD drive, thumb drive. So this is basically input-output device as a hardware, and a main memory where you all the instruction you need to control the hardware must be reside in the main memory. And then you have a central processing unit. The brain of a computer controls the operation of the entire computer systems. Consists of circuit of chips to control chips, meaning that a lot of transistors. Okay. To control the interpretation and execution of the instruction. So the features of current OS are based on users' need, support for multimedia applications, internet and web access, client server computing, and so on. So many programs now. If your PC is up to date, is powerful, you can run a lot of programs. You can install a lot of things on your PC, especially those for gamers. They use really like powerful speed, and you must have a GPU as well. Now they have a GPU, graphical processing unit for basically on image. Some jobs now are divided between the CPU and of course the GPU for the modern one. So the system architecture for current OS has been improved in the way components are programmed and organized. It also uses object-oriented design, reorganization of a kernel. Kernel is the core of operating system that handles everything. Okay, kernel, core of operating system, heart of operating system that control everything in the OS. The kernel itself can be said like control the machine as well. So the kernel is the part of the OS, a heart of it that resides in memory all the times. Okay, there is a specific special allocation in the memory itself for the kernel of the OS. So this is the early OS design, entire OS in main memory and available memory for application. You can see that OS take a lot of a lot of space in the RAM. So this is the RAM. So entire OS in the main memory take a lot of allocation in OS. Available memory for application. So they just like say if you have a 8 megabyte RAM, 8 megabyte. Last time it's 8 megabyte. 32 megabyte RAM. 16, almost 16, half of it is occupied by the OS. Meaning if you install Windows 98, almost half of it occupied the RAM. So you have a very little space to execute, or very little space to allocate your jobs or applications. Okay, this is the early OS. And the kernel also in the early OS was very large and included all functions such as memory allocation, process scheduling, device allocation. So if you want to add a new components or modifying existing components, it will take a lot of time and it's a time consuming. It's a tedious process. Okay, but the benefit of it, you can learn a lot of it. I mean, it's not automated. Everything you have to like run a command line. A very you must be very knowledgeable in hardware and of course software in the early OS. Not many people, not many. It's not really user interface friendly. And now you have current OS. So object-oriented OS, the current one, you have OS kernel in main memory. Kernel is limited to few essential functions. Like very important, kernel is still a core or heart of the OS, but they have functions like process scheduling, process scheduling, and memory allocation. So this is a very important. This is a important jobs. This is the kernel jobs for the current OS, for the object-oriented OS or the current OS. How this function and memory allocation model if memory allocation module if needed, and available memory for applications. So OS networking functions if needed, OS file manager if needed, and OS device manager if needed. So this is a very flexible in a way, flexible. So it does not take a lot of, it doesn't take a lot of space for the current OS in the RAM memory. So you have a lot of slots to run your applications. Okay. So it's also easier to add new components or modify existing components. Okay, it works well in the distribution systems. So let's say if you don't have device manager, of course you need file manager, of course you need, and all that. So you take a little bit of the allocation module if needed. If you don't use that anymore, it will deallocate. Okay, the memory will deallocate and available memory application will be increased, so you can done the job faster, much more uh, much more optimum in your any of your application, any of your running application. So another important improvement is the introduction of threads. Threads is a smallest unit part of thread. Thread is okay. You have a job here, and you have a process one, process two, and process three. And process, you can classify it into thread one, thread two, thread three, and so on. Thread one, thread two, and so on. So thread is just like the smallest units between the job, process, and the threads. A process has two characteristics. It requires, okay, process has two characteristics. It requires space in main memory where it resides during the execution. From time to time, it requires other resources or data files. Okay, it requires space in memory. So process must have a space in main memory where it resides during the execution. So it's very important. You allocate a process one in any of the any available slot in the main memory. From time to time requires other resources or like data files. It passes through several states: running, waiting, ready. As I said, there's a 5 states, which is hold, ready, run, wait, and finish. From its initial arrival to its completion, from whole to finish. Okay. In modern OS as well, processes are switched between main memory and secondary storage during the execution. In conventional process known as heavyweight process, this incurs high overhead because for each swap, all process info must be saved to preserve the process integrity. So process are swapped between memory and secondary storage during execution. So you have a here a CPU, then you have your RAM, and you have also here a secondary storage, which can only accessed by RAM. CPU cannot straightway jump to secondary storage. CPU will always interact with RAM, RAM with the secondary storage during execution. Okay, so this again, why this is why is it designed like this? To make everything in the PC is the speed. The most important thing is the speed. Second, maybe the speed, but sometimes speed you take a lot of resources which can hit, you can hit the machine, or you take a lot of you utilize more of the CPU or memory space. So this is a trade-off. More speed meaning that higher utilization, but that's why from time to time the modern PC they try to increase the CPU speed, increase the RAM increase the RAM memory and stuff, because why they want to make it faster. But this all comes to like PC can become uh, PC can become like heated easily and stuff. All right. So again, a thread, as I mentioned before, is a small unit smaller than a process, can be scheduled and executed. The heavier process which owns resources becomes a passive element. And the thread becomes the element that use the CPU and is scheduled for the execution. Swapping a thread is less time consuming than swapping a process because there is a less info to be saved. So again, the heavy process which owns resources become a passive element. So you have a big process, chunks of big process. You can break it into several threads. The thread becomes the element so that use CPU and schedule for the execution. So instead of CPU execute the process, CPU will execute the thread first. Okay, and swapping a thread is less time consuming than swapping a process. So because of the smaller size of the thread, uh, use a less info, and of course your execution of a thread is much more faster than execution of a process because of the smaller size and easier to process. Okay, so this is a thread CPU, this is a process, and this the largest one is a job. Okay, but now if you go to the Intel, if you go to like what is the latest Intel processor, they will tell you how many core they have and how many threads they can handle at one time. Okay, so thread is a new things because a smaller thread you can execute a thread which is a much more faster components than a process because of the smaller size and less CPU utilization. And of course, you have a multi-processing where two or more CPUs share the same main memory. Okay, you have like this is the RAM 1, RAM 2, RAM 3. Okay, all shares the sorry, so, so this is CPU 1, CPU 1, CPU 2, and CPU 3, and all share the main memory or RAM. With two or more CPUs share the same memory, most IO and the same control program routines. So the service the same job stream and execute distinct processing programs concurrently. So you can do a multiple program, parallel programming or parallel process, which is can execute, of course, faster. As I mentioned before, the goal is to make your PC or your machine execute faster for any applications or programs. But both the hardware and software must be compatible. As I mentioned before, last time, yes. Is it mute again? No. Okay. I know it's a 1 hour, but we have only 4 slides to go, so we'll finish. A normal class after 1 hour, I will take a break like 5 to 10 minutes, and then we can continue. But since we only have 5 more slides, so we will continue. This is an introduction class, so it's not really heavy. Just no, just a brief overview of everything in the OS. Okay, multiprocessing. You have a multiple CPU. You can have a CPU or you can have a one chip that have a single independent CPU. Okay, like Intel 4 core, Intel 8 cores, and something like that. And you have a symmetric multiprocessing allows several CPUs to process multiple jobs at the same time. The CPUs are independent of each other. Each CPU has access to the OS. They share memory and secondary storage device. So you have a symmetric multiprocessing, which is much more faster, okay, than the multiple processing itself. Okay, some of the processor dependent on each other, but for the symmetric multiprocessing, each CPU is independent of each other. Okay, you can put other jobs that is not related to other CPU as well, so that that CPU can run that jobs or process or threads. So this is a typical setup of multiple processors. Uh, if there are five, it can run up to 5 processes simultaneously. Okay, of course, main memory also must be, your RAM also must be very big to be compatible or able to withstand all the CPU, all the CPU that installed in that machine. So in asymmetric multiprocessing, some OS functions are assigned to subordinate processor which takes the instruction from the main CPU. Some OS functions are assigned to subordinate processors. Each instance with one processor, all these scheduling and program computations are managed by the CPU. If a second CPU is added and assigned to responsible for this scheduling, then upon request from the main CPU, this processor executes its own algorithm to handle requests. So meaning that in asymmetric process, you have a main CPU, which is the top of the hierarchy, and of course you have a secondary CPU, third CPU, or something. So if a second is added and assigned to for this scheduling, then upon request from the main CPU can request the secondary CPU to execute its own algorithm to handle requests for this access or something like that. This is asymmetric multiple processing. For the symmetric multiprocessing, each CPU is independent of each other. Okay. Asymmetric, you have a main CPU and you have a secondary or third CPU. And of course, you have a network manager, those who you handle the printer sharing, file sharing, folder sharing, everything. You want to share photos, you want to share files, whatever. Okay, database and cloud computing. So cloud computing meaning that you have a multiple machine that share resources, doing the that share resources and doing the jobs that, of course, you make much more faster. Is it's one of the key technologies of moment. If you have a cloud company, let's say you want to host, you want to have a company like servers and stuff, database, you can host it on a cloud computing instead of have a physical location, one server room, which is expensive. You have to handle the electricity, you have to handle the heating, everything, wiring and stuff. Other than having that, you can of course outsource it to the, you can host it on the cloud computing, which much more easier, right? So how it changes the role of OS. It allows us to accommodate remote access system resources, provide increased security. Of course, if you have, let's say you have a PC and you don't have enough fund to buy a Microsoft Office and stuff. Of course, you have an internet, you have a browser Chrome, which is free. You can use a Google Office or something like that. Okay. So this is you can run OS, you can run some applications in the you can run some applications in the cloud computing. Okay.